So with 11, let's see what number we are on. We're on 11.14. Okay, we're going to distinguish. We're going to start by distinguishing between unidirectional and bidirectional DNA synthesis or replication. Let's see. Synthesis. Okay. So essentially what that means is when DNA is replicated, okay, we'll start with a piece of DNA here. So during replication, we're going to get this replication bubble here. And so if DNA was replicated in one direction, let's say unidirection, this would be unidirectionally. That's kind of a funny word. Unidirectional, I guess that might make more sense. So if it occurs in one direction, then the DNA polymerase will get on here and it will just go that direction here, one or the other. Won't go the other way. So that's unidirectional replication or synthesis. Now if DNA is replicated in both directions, if it's bidirectional, so DNA will be replicated that way and this way. So we'll have like two polymerases associated with this replication bubble here, and two forks, one fork over here, one fork over here, and DNA replication will go this way and that way in two directions. So that's pretty easy. Now the next part of this question was to distinguish between continuous and discontinuous synthesis of DNA. So I think the easiest thing to do here is, take a look at our previous diagram here. Let's just take one of these replication forks here. Let's just consider one direction. Oh, hey, that's a band name, right? Yeah, okay. I didn't mean to say that. So I don't even know what they sing, really. I think they're pretty good. I think I like them, though. Anyways, we're just going to consider one replication fork, and you can assume that both, what I'm going to diagram here is occurring on both forks. So here's a replication fork, and we're distinguishing between continuous and discontinuous synthesis. So this is the DNA that's being replicated, and I'm going to put a 5' end there, 3' there, 5' here, 3' here. And I'll put the little DNA nucleotides on the strands here. Now one of these strands is going to be replicated continuously and the other is going to be replicated discontinuously. So we talked about in the previous question, 11.12, how the DNA polymerases have a property that allows them to replicate from the 5' to the 3' direction. So in here we would need an RNA primer put in first, but 5' end is on the left, and so this polymerase here, it can start at this RNA primer, and this DNA polymerase can continue to replicate without stopping. So it can just keep going, So we'll have the helicases unwinding here. We'll have DNA gyrase relieving tension down here. We'll have single-stranded binding proteins keeping the DNA from coming back together before it's replicated. And this polymerase here, it can just keep going continuously. So this is continuous replication. And this is also called the leading strand. The leading strand is replicated or synthesized continuously. However, now this strand up here is going to be called the lagging strand. And we can put an RNA primer here. And so this little piece can be replicated, right? Because the 5' end is here, and the 3' end is here. But eventually, you know, it can't keep going, right? Because the fork is moving this way. And so as this part of the DNA becomes available, well, we're going to need another RNA primer put down here, and then we're going to need the DNA polymerase to actually, you know, come back and replicate that little piece. So this is discontinuous synthesis, the lagging strand here. The lagging strand is synthesized discontinuously. Lagging strand discontinuously. And I don't expect you to be able to read that, but hopefully you're listening to me as I'm writing that, and you're able to take some notes on it yourself and write it more clearly. Okay, so that's the difference between continuous synthesis and discontinuous synthesis.